Making this video as a just an addition to the Unit 1 review that we did in class in case anyone missed anything. We're going to go through this. Of course, if you have any questions, you can still reach out to me through email or through Schoology. A couple of things that I want to point out to you. On your exam, you're going to have a mixture of about 3 different types of questions. So there are going to be multiple choice questions. There are going to be word bank questions. There are going to be fill in the blank questions. And there's going to be some math, like the density problems that we did. Okay, so let's take a look at our first page here. So the first page says, what is the definition of matter? So we talked about this way back on the first days of school. So we said that matter is anything that has mass and takes up space. So anything that has mass and takes up space is going to be considered matter. The next part is looking at what are some 3 examples of matter. So again, these are up to you, but just for 3 examples, I'm going to put this marker, perhaps a glass of water, and the air that we are breathing. All of these are examples of matter. Now, I picked these 3 examples on purpose because I picked one example that was a solid, one example that was a liquid, and one example that was a gas. But that was just to illustrate that not all matter is one type of material. It could be a solid, it could be a liquid, or it could be a gas. Okay, let's take a look at our next slide. So in our next slide, we have this chart. So you're not going to get a chart like this to fill in, but what I might do is I'm going to ask you multiple choice questions that you can answer by looking back at this chart. So the first thing is that we're going to talk about the spacing between molecules in a solid. So this is the smallest amount of space between molecules. And if I were to draw a picture of it, I would show the molecules very close to each other. For a liquid, we have more space between molecules. More space than a solid. And this might look something like this. And then for a gas, we have the most space between molecules. They are really far apart from each other. They're spaced out all over the place. Okay, for the volume line, what we're going to say is that it has a definite volume. So whatever if this is our substance here, whatever the volume of that is, it's definite, 100% the same all the time. Same thing with a liquid. We're going to say that it has a definite volume. So if we imagine our liquid here, we could measure whatever volume that is, it would be the same. And then for a gas, it has an indefinite volume. So what I mean by that is if we have a large container like this, it'll fill up that container. And if we have a small container like this, it'll fill up that container. So it will expand to whatever container it is confined to. Okay, the shape. This has a definite shape. So when we did this in class, I joked that it could be, you could freeze something in the shape, whatever shape you want. You can make it look like Mickey Mouse, you can make it look like a triangle, whatever shape you want. It has a definite shape. So when you take it out of that container, it'll stay looking like that. This liquid has an indefinite shape. It will take the shape of whatever container it is in. So if this is our container, this square, it'll look like that. And of course, a gas will also have an indefinite shape. That's why we can have gases that are in balloons that look circular. We can have gases in balloons that look like Mickey Mouse. We can have gases in balloons that look like a sword. Whatever your balloon shape is, that's the shape that that gas will take. And then finally, how fast they're going, the speed of these molecules. These are the slowest. These are quicker, and these are the fastest. So fastest moving are the gases, slowest moving are the solids. Okay, if you need to look at this for a minute, just pause the video. Otherwise, we're going to continue on. So if we take a look at our next slide, it says complete the graphic to show energy being absorbed and the changes in matter that happen. So if we have something that looks like a solid to begin with, this is our solid, and then we add energy. It's going to, this is called melting it. It's going to turn into a liquid. And a liquid is going to have molecules that kind of sit along the bottom here in whatever shape that container is. And then if we add more energy, it's called boiling, we'll get a gas. So again, if you need this slide, just hit pause on the video. Otherwise, I'm going to continue on. Okay, if we look at our drawings for each of these, so we have an element, a compound, and a mixture. So if we want to look at an element, we have a single type of atom. So it might look like this. If we have a compound, we have two or more, so two plus elements that are bonded together. The last one is a mixture. So we have a mixture, we might have elements, we might have compounds, so here we have combination of different elements and or compounds. So for this question, I might draw these three pictures and I might say, which one of these represents an element? Or which one of these represents a compound? Or which one represents a mixture? So I can make a picture like this and ask you those questions. So for this one, I'm going to have a flow chart already made. You're going to choose from these and put them in the correct spots. So we're going to draw the chart first. This is what our chart is going to look like. And if we start all the way at the top, so we're going to have matter. Let's cross that out. And then the two different types of matter, again, we did this way back in early September. So we have a mixture or a pure substance. And then each of these can further be broken down into homogeneous and heterogeneous. And then on the pure substance side, we could have an element or a compound. And then if we wanted to identify an example of each of these, so a homogeneous mixture could be something like Gatorade. A heterogeneous mixture could be something like Raisin Bran cereal. Or a chocolate chip cookie or something. An element could be something like aluminum or copper. And then a compound could be like carbon dioxide. Okay, if you need this, please pause the video. Okay, so the next question here says, what is the main difference between a compound and a mixture? So a mixture, let's start with compound. Compound is a single substance with two or more bonded elements. A mixture is a combination of two or more different substances. Okay, so question 7 says, what are 4 physical properties that we can observe? So physical properties are things that we can see for the most part. So we can write texture, color, mass, boiling point or melting point, temperature. Let's see, density, volume, odor, like what something smells like. The bottom one down here says, what are two examples of chemical properties? So chemical properties could be things like if a substance is flammable, or if a substance is corrosive. So if it eats away at metals. So those are examples of chemical properties. So now let's take a look at the next slide. So in this question, it says, what makes a physical change different than a chemical change? So in a chemical change, chemical change will form a new substance. You have to form something new if you undergo a chemical change, or you could take something that already exists and break it apart, forming new things. So a chemical change forms a new substance. A physical change does not form a new substance. And then provide 3 examples of physical changes. So changes that do not form a new substance. So we could say something like melting an ice cube, or tearing a piece of paper, or chopping up a log. Those would be examples of physical changes. Okay, let's take a look at the next one. So we saw this in our guided notes with a couple of pictures. So write 4 pieces of evidence that show a chemical change has occurred. So here, we're going to say bubbles, if we see bubbles form. A second one could be a color change. The third one could be a change in temperature. And then finally, the fourth one could be formation of a precipitate, like a solid that forms. All right, let's take a look at the next one. So now we're going to look at some density problems. And when you see this on your test on either Thursday or Friday, depending on what class you're in, when you see this on your test on Friday, you might have a question that asks you to find the density, a question that asks you to find mass, or a question that asks you to find volume. So I'm going to give you, and I'll give you them on the test, all 3 formulas. So we have density equals mass divided by volume, or mass is equal to density times volume, or volume is equal to mass divided by density. So these first two problems, we're going to be looking for the density. So the first one says a block of aluminum takes up 15 milliliters of space. That's your volume. Volume equals 15.0 milliliters. And the second part is the mass. So the mass is equal to 40.5 grams. So we have density is equal to 40.5 grams divided by 15.0 milliliters. Now, in your calculator, you could type 40.5 divided by 15, and you get an answer of 2.7 grams over milliliters. Okay, so letter B, we have a solution of sulfuric acid, and it says that it has a mass that is equal to 65.14 grams and a volume that is equal to 35.4 milliliters. So we're going to solve this same way. Density is equal to 65.14 grams over 35.4 milliliters. So we could type that in, 65.14 divided by 35.4. We get about 1.8 grams over milliliters. Okay, for our next part here, it says a sample of liquid mercury has a density of 13.6 grams per milliliter. So we have density equals 13.6 grams over milliliters. If the volume, so the volume is equal to 22.5 milliliters, what is the mass? So now we're not going to use this equation, we're going to use this one that says mass equals. So we have mass equals density times volume. So my density, 13.6 grams per milliliter, and my volume, 22.5 milliliters. So I can type that into my calculator. So I have 13.6 times 22.5, and I get an answer of 306 grams. The last one, we have a sample of iron has a mass of. So mass equals 28.5 grams. If the density of iron, so they give you the density of iron is 7.7 grams per milliliter, calculate the volume. So now we're going to use this last equation, volume equals mass divided by density. So the volume is 28.5 grams. The density is 7.7 grams per milliliter. So I can divide those two numbers. And I get an answer of 3.7. Alrighty, so I'll step out of the way here so you can see this. So just a couple of quick notes about our first exam. So please come to class at normal time. Once we get started, you'll be put in a breakout room by yourself. That way, if you have a question during the test, you can call me into your breakout room. You are free to use any materials that you would like, so you can go back and look at past notes. You can look at any of the assignments that you've turned in. You can look on the internet. You can look anywhere you would like. You're to complete the exam during the class period. If you need more time, you can let me know and we can work something out there as well. And if you have any questions during the exam, you can call me into your breakout room and I can help you with that. Again, we're going to have a mixture of multiple choice questions, fill in the blank questions, pulling from a word bank type thing. We're going to fill out the chart, and then we're going to have some math problems like the ones that we finished up with right here. If you have any questions between now and then, please feel free to reach out either through email or using the Messenger Schoology message function. All right, hope everyone studies really hard and that everyone does great. See you guys.